Good morning, students. Uh, I'm V. Karpuri, Assistant Professor, Triple Department, working in RMD Engineering College. Today, I'm going to present on basic electrical and electronic measurement with the subject code BE8255. And the topic that we're going to see today is elements in electrical circuits and Ohm's law. Okay, so directly we'll go for the topic. First, in the electrical circuit, what are the elements that we actually see? Okay, so elements are of energy sources. The main element is the energy source. So this energy source can be either a voltage source or a current source, and these are all called as active elements. So there are two different types of elements. One is the active element and the other one is the passive element. So you can see here, one is the active elements and the other one is the passive elements. So active elements are the one which is capable of delivering power to some external devices. So if it delivers power, then it is called active element, and if it is receiving the power, it is capable of receiving the power, then it is called passive elements. So voltage and current sources, so all these sources comes under the active elements, and resistor, inductor and capacitor, that is R, L and C, comes under the passive elements because they can only receive power and they cannot give the power. Now, so the symbol for the different elements that we are going to see here. So the passive elements, first we'll see what are the passive elements. So resistor, which is denoted by the a resistor, which is denoted by R, and inductor by L, which is in this shape, and a capacitor C with two straight parallel lines or the curved lines. The curved line here shows the capacitor. If it is a DC case, then it will be a straight line, two straight lines like this, in case of a DC, and you will have a curved line like this in case of a AC. Okay, so this curved line shows the capacitor in case of a AC capacitor. So generally resistors, inductors and capacitors are denoted like this. Now coming to the active element. Active element are nothing but the voltage source and the current source, as I said you. So these are the voltage sources. You can see that as two straight lines denote that it is a DC supply denoted by plus and minus, or I can even represent it with a circle. Inside a circle I can give the terminals. This is very important, the positive terminal and the negative terminal. And the current source, is represented by arrow mark. The current indication is represented by the arrow mark. So these are all the DC sources. So you can see these three are all DC, comes under DC. Okay, this three comes under DC and this comes under AC. Okay, if I draw it using a sinusoidal waveform, then it comes under a AC. So this is the how the AC sinusoidal voltage is represented. So these are all called as independent sources. So they don't depend on anything. Just if I give a source, it will act as either a voltage source or as a current source. Okay. Now dependent sources. So what is the dependent sources? When it is going to depend on some other values. For example, it might depend upon the current flowing through the circuit, or it might depend upon the voltage flowing through the voltage across the circuit. Okay, so these are all the dependent sources and they are represented by a diamond shape. So the independent sources are represented by a circle shape and dependent sources are represented by a diamond shape. So this Vs is going to depend on some current or the voltage. So for example, let me take the current flowing here, let it be I1. Okay, then what will happen? The voltage source Vs or somewhere here, like there is a resistor like this, and if the current flowing through the resistor is Ix, let me take it as IR. Okay, the current IR. Next, so what is my Vs is going to be some A times IR. Okay, so this is called as the dependent source, and its value keeps changing depending upon the current flowing. So when Vs is equal to A into IR, then it is called as dependent source, which means that this source voltage will depend upon the current flowing through this resistor. Okay, so that is the meaning. So these are the dependent sources, and the dependent sources are represented by the diamond shape. Okay, so this is just an example for you to understand it. So I will write Vs is equal to IIR. Similarly, a current source. A current source is also indicated by a diamond shape with an arrow mark in it, and it might depend upon either the voltage or the current flowing through any of the element. Okay, so these are all the active element and the passive element. Next, coming to the Ohm's law. So what is Ohm's law? You would have already studied. This Ohm's law is nothing but it is the potential difference or voltage across two any ends of a conductor is directly proportional to the current flowing through it. So that is called as Ohm's law. So what is Ohm's law? It is the Ohm's law is the potential difference across any two ends of a conductor. That is, Ohm's law states that the potential difference across any two ends of a conductor is directly proportional to the current flowing through it. So this is the voltage source. This is the current. So V is equal to I. Actually, voltage is proportional to the current when it is seen. It provided the temperature remains constant. Provided the temperature remains constant. So the temperature should remain constant. So this Ohm's law is valid only when the temperature remains constant. Okay, so V is equal to, actually voltage is directly proportional to the current. That is, the voltage across the circuit is directly proportional to the current flowing through the conductor. So this is the conductor. Okay, so this is the conductor C. So the current flowing through the conductor is directly proportional to the voltage. So to remove the proportionality constant, we are going to introduce proportionality sign. We are going to introduce a constant called as R. So this R is nothing but the resistance of the conductor. So we can say that Ohm's law is directly, Ohm's law states that the voltage across the ends of any two conductors. So this is one end and this is the second end. Okay. So the voltage across any two ends of the conductor is directly proportional to the current flowing through the conductor. Now let us see some problems. For example, I am saying a current of 0.5 amps is flowing through the resistance. So I will have a resistance here and a current of 0.5 amps is flowing through this current. Okay, and you will have the find the potential difference. So they are asking you to find out the voltage. So this is the small problem based on Ohm's law. So what is Ohm's law? V is equal to IR. So this is my small circuit. Here I can say that current I. So this is the current I, and this is equal to 0.5 amps, and resistor R, which is equal to 10 ohms. So this resistance R is 10 ohms. And so how will I find out the potential difference V? So we know that V is equal to I into R. So it is 0.5 into 10, which is equal to 5 volts. Okay. Now, second problem. So supply voltage of 220 volt is applied to a resistor of 100 ohms. So we have a resistor here. So the same circuit. So I'll redraw it. Again, we have a resistor of 100 ohms that is being connected to a supply of 220 volts. So this is going to be a 220 volts. I can even draw like this 3-4 lines. Okay, now this is the resistor R of 100 ohms. Okay, this is the resistor R of 100 ohms, and the supply voltage is given as 220 volts. Okay, now 220 volts is given. Now they are asking you to find the current. So we know that the current I is equal to V by R, because R is equal. So this current I we have to calculate. Okay, so now I is equal to V by R. So 220 divided by 100. So 220 by 100 is equal to 2.2 amps. Okay, the third problem, we are going to find out resistance. So anything can be done. I is equal to V by R, V is equal to IR, and R is equal to V by I. Similarly, if they ask you to find out the resistance, you can say that the potential difference 6 volts divided by current 2 amps is going to give you 3, and unit of resistance is ohms. It is given by, since it is, this is the Ohm's law, so the current is given by, it was specified by an scientist, Ohms, and hence the current through the conductor depends upon the resistance of the material, which is, whose unit is given by ohms. Okay. Next, after finding out the current, resistance, and the potential difference or the voltage across a conductor, we will go to find out the power. So we know that power is equal to V into I, the product of voltage and the current. So what they have asked, calculate the current and resistance of a 100 watt 200 volt electric bulb. So power they have given as 100 watts and the voltage is 200 volts. Okay, so now what is, we know that power P is equal to V into I. So how much current is consumed? It is equal to P by V, which is equal to 0.5 amps, and the resistance R is given by 200 by zero point 0.5 voltage is equal to 200 divided by zero point 0.5 current, that what we got from here. So the resistance is not 400 watts, it is wrong here. The resistance is 400 ohms. Okay, so the resistance is 400 ohms, which is denoted by a symbol like this. Okay, now calculate the power rating of the heater coil when used on 220 volt supply taking 5 amps. So the voltage is 220 volts. The heater coil, it is just a coil that is used to heat the water. Okay, so we are going to find out the power rating of that coil heater, uh, immersion heater. Okay, so now what is the voltage given? 220 volt. Current is taken as 5 amps. So power is equal to V into I, and power is usually denoted in watts. Okay, it is also a scientist name. His name is Watts. Okay, so you know all this. Power is given by Watts. WATTS. Now I can write like this. Okay. But units are always written in small letters, so capital letters are not allowed. So it is WATTS. Okay. The first letter is capital letter. See, you can see here. Amps, or you can even write it as watts. Okay. Now we'll see each and every element. The resistance. Okay, so the property of a material, what is resistance? So we will take every element and we'll find out, study what are all these elements. Okay, so now resistance, the property of a material to restrict the flow of electrons, flow of current is called resistance, which is denoted by R. Okay, so voltage V is equal to IR and current I is equal to V by R. So every material has some resistance, that is, it does not allow the current to flow through it easily, and the volume of the current flow, or the amount of current or the electrons that it passes through the conductor, is depends upon the material property, which is called as resistance. Okay, so that is what is resistance. Okay, like, and its voltage V is given by, so as we have seen, that is Ohm's law. So Ohm's law is applicable only for resistors, and this is true only at constant temperature. When temperature changes, automatically Ohm's law is not valid for any material. It is not valid for this material, and Ohm's law is only applicable for constant temperature. And we also know that substituting all these values, the other formula for power is also find out. That is, we know that power is equal to P is equal to V into I, or it can be also power is equal to I square R or V square by R. Next, the energy that is dissipated by the resistor, because resistor is a heating element. The element gets heated, and the energy that is saved in the resistor is dissipated as heat, whereas the energy that is saved in inductor and capacitor are different, and that we will see later. Okay, so the energy that is saved in the resistor is dissipated in the form of heat, and it is given as integral of PdT, which is equal to PT. So which is nothing but power is equal to I square RT or V square by RT, and unit of resistance is ohms, and unit of energy, the unit of energy is consumed, that is power is given in watts, and the energy is also given by V square by R into T. So that is, we'll substitute I is equal to V by R, so V square by R into T. Okay, next comes the inductance. So what is inductance? A wire of certain length, when twisted into a coil, becomes a basic inductor. So you can take any wire and you can twist it so that it becomes a coil and it becomes a basic inductor. Okay, now what is this inductor and what is the energy stored in the inductor? So how it is going to differ from resistor? So we're going to see a three elements: resistor, inductor, and capacitor. The that is, the material property of the resistor is called as resistance, the property of the inductor is called inductance, and the property of the capacitor is called as capacitance. Okay, now the current flowing through the inductor does not allow sudden change in the flow of current, and the change in this current produces change in the electromagnetic field, which induces a voltage across the coil. So when current flows, that is, when the current linking with the coil, so that is called as current linking with the coil. So when the current links with the coil, what happens? A small amount of flux is being developed, or there is a change in the electromagnetic field. So this field will induce a voltage across the inductor, and this ideal inductor, what it does, it will oppose sudden change in the flow of current. That is what is given here. Ideal inductor offers opposition only to change in the current or flux. Okay, actually I've striked it off. So the inductor offers opposition only to change in the current or the flux. So it does not allow sudden flow in the change of the current. These are all the property of an inductor. So the property of opposition to change in the current is called inductance, and it is denoted by L. So this property of opposing, like resistor out opposes or the flow of current. Similarly, what happens in inductor? The inductor opposes the change in the flow of the current, and this property of the inductor is called as inductance, and it is denoted by L. And inductor stores energy. So here inductor stores energy, whereas resistor dissipates energy, and inductor stores energy in the form of magnetic field. So this is very, very, very important. Okay, inductor stores energy in the form of electromagnetic field, and that is called as EMF. Okay, so inductor stores energy in the form of electromagnetic field, EMF. Okay, and it is given by V is equal to L into di by dt. What is di by dt? Differentiation of current with respect to time. What is this differentiation? Small di represents small change, which is nothing but delta. So delta is always represented as small change. So the small change in the value of current with respect to time induces the voltage V, or it develops, that is voltage across the coil, that depends upon the property of the inductor called inductance. That is why it is given as V is equal to L into di by dt. Now from this V dt is equal to L into di, just we are getting it small equation and integrating it to find out the current. So find out the current I, what should I do? I will keep di on one side and move all the other component values to the other side. So LHS I've kept only I. The remaining all I've moved here, and I have found out that current I is equal to 1 by L, because L is a constant, so I can take out of it. Okay, so L if it comes out, it becomes a 1 by L this side. So 1 by L is integral of V dt. So the current flowing through a inductor is given by 1 by L integral of V dt. So remember these two formulas, these are very important. So L into di by dt, voltage with you will get di by dt, and for current you will get integral of V dt. Okay. Now the power absorbed by the inductor. So we know that power is equal to V into I. So multiply both L into, what is V? L into di by dt, keep I same. So it is nothing but Li into di by dt. So power is equal to Li into di by dt. Now energy stored in the inductor. The energy stored in the inductor, again 0 to t pdt. So substitute the formula L into I di by dt, which is equal to Li square by 2. So the energy that is stored by the inductor is given by Li square by 2. Okay, the unit of inductance is Henry. So this is very, very important. The unit of inductance is Henry, and it is denoted by H. The unit of resistor is the property of the resistor. The resistor has a property called resistance, whose unit is given by ohms, and it is denoted by R. Similarly, the unit of inductance is Henry, and it is denoted by H. Okay, next coming to the next topic, capacitor. So the capacitor possesses a property called capacitance. What does it say? Any two conducting surface separated by an insulating medium exhibits the property of a capacitor. So if I say any two plates, so these are called as parallel plates. Okay, this parallel plate is having an insulating medium in between it, and so that any two conducting surfaces, so these two are surfaces separated by a insulating medium. So this is the insulating medium. So when it is separated by an insulating medium, then it is called as a capacitor. Now what is happening here? Energy is stored in the form of an electric field that is established by the opposite charges on the two electrodes. So depending upon the charge that is seen, it might be a plus charge, positive charge here, and it is a negative charge here. So depending upon the charge that is being stored, that is given across the capacitor, that establishes a electric field opposition for the charges, that does not allow current to flow through it. Okay, so this opposition is called as capacitance. So always everywhere it is opposition, whether it is a resistor or an inductor or a capacitor. And the ideal capacitor offers opposition only to change in the voltage. So there it offers so this offers opposition to change in voltage. Here you can see the inductor offers opposition only to change in the current. So only I say di by dt. Okay, change in the current. When there is a change in the current flowing through the inductor, voltage is being induced across the inductor. In case of a capacitor, when there is a change in the voltage, opposition only to change in the voltage, then what is happening? That opposition is called as capacitor, and we say a current flows through the capacitor. So this property of opposition is called as capacitance, and it is denoted by C, and the unit of capacitance is farad, and the capacitors are denoted in terms of F, like 10 millifarad, 100 microfarads, then 100 farads. So these are all the different values of capacitor. Similarly, for an inductor, you can see it is millientries, microentries, and in terms of entries. Okay. Next, so capacitance. The formula for capacitance is C is equal to Q by V. What is Q? It is the charge stored. That is, the capacitor charge stored across the capacitor is given by Q, and V is the voltage across the capacitor. Okay, so the voltage or the potential difference across the capacitor is given by V. So the capacitance depends upon charge. Q is nothing but charge, and V is the voltage. Now, what is the current flow? The current across the capacitor, that is what is given here. See here, it offers opposition only to change in the voltage. So I is equal to C into dV by dt. So from that I get the voltage is equal to 1 by C integral I dt, and I is equal to change in the voltage of the capacitor. Okay, I is equal to C into dV by dt. Okay, now the power absorbed by the capacitor is P is equal to V into I. So multiply that, keep V constant, C into dV by dt is taken, because current I is equal to C into dV by dt, and P is equal to V into Vc into dV by dt. Now energy stored, the same formula. It is nothing but the rate of change of power. That is your energy. Okay. So 0 to t integrated, and substitute the value of power into dt cancel. So integral of Vc into dV. So C is a constant. So I take C outside. Integration of V into dV is nothing but V square by 2. Okay, so that is how I get the energy stored in the capacitor is equal to half CV square. So this is the summary of the voltage, current, power, energy. So we can see that the resistor, the voltage is V is equal to IR. Inductor, it is L into D. That is the rate of change of current. Only when there is a rate of change of current, voltage is being induced. And similarly for capacitor, when there is a rate of change of voltage, current flows through the capacitor. Okay, so these are the voltage, current, and power and energy for three different elements, namely resistor, inductor, and capacitor. Okay, so these are the basic elements, their voltage, current, and power, and also the energy that is consumed by the resistor, inductor, and capacitor. And also one more thing to say, the energy stored in the resistor is not stored, it is dissipated in the form of heat. Only resistor dissipates energy in the form of heat, whereas inductor, energy is stored in the form of electromagnetic field, and then capacitor, the energy is stored in the form of electrostatic field. Okay, so these are the basics of elements in a electric circuits in Ohm's law. Thank you.